So can I start my lecture? Hello. Very good afternoon, students.
Good afternoon, sir.
Previously, we just started about previously I just started directly. So I want to tell about myself. I'm Rajesh Kumar. I've done my MTech in petroleum exploration, and after that I just worked in oil industry, mainly for ONGC and GSPC. I worked for contract basis. On contract basis, I worked for these two companies, mainly in the different areas in the drilling as well as production operations. So one region I worked in Gujarat and other one in Andhra Pradesh itself. Next, up to 2012, I worked with those two companies on contract basis. After completion of the project, I joined in education sector. So my first college, which I joined in petroleum engineering college in Aditya Engineering College, that is in Kakinada. After that, in 2015, I joined in K University in Vijayawada. So presently, I'm going to take these particular topics for you. Um, so there is, can you see my slides?
Yes, sir.
Okay.
Yes, sir.
So here, whatever we just seen earlier, that will be coming under well logging, or it is termed as formation evolution. Okay, well logging, that is when you want to see some sort of subsurface formations, how your rocks are there, what is the stratigraphy or what is the lithology, where your hydrocarbons are present. One sort of tool you can just see the background side. One sort of tool which is lowered into your wellbore. Okay, and this one you can just see some sort of waves which are passed into your wellbore, and you'll be just seeing some sort of record. That is your well logs. So here, previously we just seen about petrophysical properties of rocks, that is porosity, permeability, hardness, and electrical properties. And next one we just seen types of well logs. So here, depending upon the formations or stratigraphy or lithology, whatever may be, so they are different categories. One is lithology logs, porosity logs, and electrical logs. So lithology logs will be your gamma like this, gamma ray, SP log, caliper log, and porosity log is sonic density and neutron. Electrical logs, all your resistivity logs, either shallow, deep, um, whatever may be. Those are electrical logs, or another one is conduction logs. And in types of logs, The types of logs itself, yes. In the types of logs itself, there are another set of classification. These are with respect to your formations. And another classification is depending upon your type of well which you just drilled. That is either it is open hole wells or case roll wells, or whether it is a deviation wells or horizontal wells. Whether it is a vertical well or case roll wells, whether you went for a casing operations, case rolls. After drilling a well, you are going for casing. Okay, whether it is open hole wells or case roll wells, whether it is a directional well or horizontal well, all multilateral wells. Okay, so like this, your types of wells, types of logs also are going to be changed. So these logs are going to depend upon your formation or lithology or stratigraphies. So what we just seen, that is open hole logs, case roll logs, deviation logs, or that is directional drilling. So those are also there at the time. Also they'll just use different set of logs. But whatever the logs which you are going to use, these logs only will be coming out. And next one we just seen basic log types. The three classification of log types we just seen. That is, while you're going on drilling, with respect to your drilling, you'll be having your measurement, that is LWD or logging while drilling. Next one is wireline logging. So this wireline logging will be done in intermediate stages, either for 500 meters, 1500 meters, 2000 meters, 2500 meters, 3000 meters, 4000 meters, 5000 meters, like this, at intermediate stages. But this logging while drilling or measuring while drilling, that is continuous. When you are going on drilling operation, this will be having an automatic record or continuous record will be there. So this is an intermediate, that is wireline logging is an intermediate. Next one is pipe conveyed logging, that is in pipe conveyed logging. So during your workover operations, or when you want to, that is assume that during your drilling operations, assume that this is the well which I just drilled. So during your tripping operations, so whatever these terminologies are there, these terminologies we are going to just see after completion of your logging operations. That is after completion of your formation evaluation, we are going to start with the drilling. At that time, we are going to just see about these terminologies. What is your open hole? What's your case roll? What is the meaning of tripping? How the string will be there, like this. Okay. But as of now, just remember these things. An open hole will be a rough type. Okay. An open hole, if you just see an open hole, it will be a rough type like this. Okay. When you just see a wavy form, that is termed as open hole. When you just see straight lines like this, it is termed as case rolls. And a straight line to the straight line, if you just see in the graph or in the diagram, if you just see an horizontal line, small horizontal lines like this. Okay, if you just see this sort of picture, whatever I just shown with an blue color, it is cased with cementation. Okay, this blue one which I represented, that comes under casing with cementation process. The zigzag one or wavy form is termed as open holes. So here, during your case roll or during your open hole drilling, at sometimes assume that this is a drill string. To this drill string, a drill bit will be attached. A bit or cutter will be attached. So this bit or cutter, some cases at some point, so due to your extreme pressures, this bit can be falling. It can fall into your well bore, or some cases will be there where this pipe will be cut into your well bore. That is, this particular pipe will be breakdown or cut will be occurring, so that this pipe will be falling into your well bores. Or during your well logging operations, Okay, this sonite, what do you just see the tool? The tool will be there. So this tool, okay, the sonite tool. So this tool sometimes a wire can be cut, and this tool can be present in your wellbore. Okay, that is, it will be just falling into your wellbore. So at that time, so we want to retrieve these particular tools. We can't just simply leave them into the wellbore. So these tools should be retrieved to the wellbore. So those operations are termed as fishing operations. So at that time, they'll just go with the pipe conveyor logging. Okay, they'll be just lowering some sort of tool to determine at which particular depth these particular tools are present. Okay, mainly they'll just use velocity tools or sonic tools. Okay, velocity, that is sound energies, that is echoes. Okay, echo system. Okay, echoes, one sort of sound energy will be created, and this particular sound will be reflecting back by hitting the source or the tool which is present in your wellbore. Okay, so like that, they'll just determine at which particular depth this particular tools are present or your string is present. And next one is common definition. What is well logging? This thing we just seen in earlier topics. Okay, so well logging is a continuous record with respect to your depths. A continuous record with respect to your depths. Okay, so this is a logging tool. So we just see the background. See, this is a logging tool, and this particular one is termed as your sonite. And you are going to just whatever may be the tool, maybe the caliper or gamma ray or neutron density of whatever may be. Okay, so those you are going to send some sort of energy. So those energy will be again reflected back. Again, it will be reflected back to your tool, and this will be represented on the plot as a graph, that is termed as your log plots. So now we are going to just see another topic that is termed as logging contracts. So here, just wait. So now we are going to just see another topic termed as logging contracts. So here, so when a company just like ONGC or in India or any other company, assume that they just drilled a well bore, maybe for 1500 meters or 2000 meters like this. So here, one sort of program should be carried out to determine your formations. Which type of formation is there? What it is? What's the lithology of those particular formations? What is the thickness of the formations? Whether hydrocarbons are present or not? Whether those particular shows are there or not. So this is assumed that this is a wellbore which was drilled. So here, during or before drilling operation or before set of plan which is going to be occurred, that is before your drilling operations. Okay, they'll be just going for bidding operation, bidding. Okay, they'll just go for the bidding operations. They'll just call different operators or contractors. Okay, so those operators or contractors, just like your Slimberger or Halliburton or Weatherford. So like this, some sort of service companies will be there. Okay, so these companies will be coming and they'll be just stating some sort of quotations, or they'll be just giving some sort of tender value per one particular well. How much cost? Maybe the cost for each and every set of things. Okay, Halliburton, Slimberger, Weatherford, these sort of companies. And depending upon their quotations or their tender value, maybe which company is going to provide the best with the lowest cost. Okay, it should be the best with the lowest price. The best value that is quality should be the best with the lowest value, low cost. Okay, they'll be terming as L1, L2, L3, L4, so on. Okay, L1 is the least, L4 is the highest. Okay, the company which is going to quote or give the tender with the lowest value with the best quality. So that particular company, that particular contract company is going to be selected by the operator, mainly your ONGC or the Shell, Halliburton, sorry, Shell or Reliance, whatever ENP companies are there. Okay. So here, these contractors will be giving some sort of specialization. They means they'll be just giving some sort of terminologies. They'll be just giving some sort of things which should be commonly present. So those are the depth charge means for the depth, maybe for 1 meter, maybe for 1 meter, 10 meters, or 20 meters. How much they are going to charge for 100 meters, 200 meters, 300 meters, or up to your TD, that is final depth, target depth, or total depth. Okay, for 2000 meters, 3000 meters, 5000 meters. Okay, what is the charge they are going to take? And survey charge. Okay, so how much charge they are going to keep? Okay, what are the type of tools which they are going to give? Maybe the caliper. For caliper, how much they are going to charge? For gamma ray log, how much they are going to charge? For STT log, how much they are going to charge? Next one is stations charge. Station, that is your the rental of your logging tools, rental of your logging persons, rental of your logging track, like that. Okay, the tool rentals. The next one is the logging unit rental charges, base rental charges, engineer charges, in-hole charges. Lost in-hole charges means isn't that when you're going for logging operations or perforation jobs at any sort of depth, isn't that this particular tool is lost? Okay, they are going to charge that particular cost also. The cables splice charge, that is cutting of your cable. Splicing is cutting. Isn't that I have 100 meters of cable, 100 meters of cable. Okay, at any point due to any sort of conditions in your wellbore, I have to cut my the cable. The cable should be cut away. Cutting off my cable. Okay. So for that one, I am going to take some sort of charge. The processing charges. That is a graph or plot is there. Plot or graph should be there. For that one, I am going to charge some sort of processing charge, data charge, the real-time data transmission charges, just like LWD, MWD charges. Okay, these are the common factors which will be included. So when they are going for the quotations or when they are going for the tenders. Okay, so by seeing all the rate, maybe generally if it is an open hole logs, so generally the cost of log entire operation per day for 1 day, they are going to charge 1 crore. Okay, the contractor, whatever maybe the contractor is there, per day they are going to just charge 1 crore. Okay, the times they'll just give the timing, exact timings. Maybe at 10 o'clock they have to reach. Okay, exactly at 10 o'clock they have to reach. They have to arrange all the things by 10 a.m. Maybe at night. Mostly they don't go for night times. Okay, logging operations, they are not going for night times. Okay, because of this particular activities that is termed as safety precautions, safety aspects. Okay, they generally at night times they don't go for either for preparation jobs or for logging jobs. Okay, exactly at the morning, exactly at 10 o'clock they have to reach. Okay, exactly at 10 o'clock they'll just come. Means before 10 o'clock they have to come and they have to arrange all their tools, and by 10 a.m. they have to just lower it into your wellbore. Okay, exactly. So per day, that is for each and every hour, they'll be just charging. If they delay, amount will be reduced or detected. So these are the things which will be kept or which will be given during the tender time. The depth charge, survey charge, station charge, tool rental, logging unit rental charge, base rental charge, engineer's charge, in-hole charge, lost in-hole charge, cable splice charge, processing charge, data charge, and real-time data transmission charges. Okay, these are the things which will be generally present in the quotations or tenders, which will be given by the Slimberger or Halliburton or Weatherford or any other company. So during the process of logging operations. So whatever the company which has given the least price with the best quality, that particular company will be selected, and that particular company will be coming for your logging operations. So this is the thing. Okay. So next one, preparing a logging program. How this particular company will be coming for logging operations. How they are going to prepare for logging operations. Okay, there should be some sort of procedure, just like how we are going to study for exams. The preparation, we don't study as it like. We don't study during your exam as they like. Okay, we'll just follow some sort of schedule and timings. At 10 o'clock, we have to complete this particular chapter. At 11 o'clock, I have to complete this particular topic. At 12 o'clock, I have to finish up this particular one. So like this, one sort of schedule will be there. The same way, during when a logging comes to your drill site, they'll be just going with some sort of procedures. Which sort of tool should be kept at the bottom, which sort of tool should be present at the at above, just like this. Just wait. So here, so after coming to the drill site, assume that this is your rig. Okay, so this is your rig which is present. So here the logging truck will be reaching to the this particular area or location. So then they'll be just lowering all the tools. Okay, they'll be just lowering the logging tools, the caliber logging, SP log, sonic log, density, like this. Okay, so whatever the required logging tools are there, those particular logging tools they're going to lower, or they'll be just placing on the ground, and they'll be attaching one to another by using this particular chain type will be there, couplings will be there. Okay, this is assume that is a logging log tool, and header will be there. Okay, header with an hook. To this hook, another logging tool will be attached. So like this, they'll be just attaching just like a chain way. Okay, just like a chain system, they'll be attaching, and they'll be just running into your wellbore. So here to this, I'll just show you. I'll be showing the pictures also after completion of this particular topic. I'll just show how they're going to do. Okay. So here, just backside of your logging truck, just termed as skid. To this particular skid, a wheel will be there, and to this particular wheel, this particular wheel is termed as drum. To this drum, a cable will be passing like this. Cable will be passing like this. Okay, everything, the tools, when they'll be just lowering or keeping, they'll be just keeping on your ground, and each and everything slowly they'll just keep on one particular sledge type will be there, that is termed as catwalk. Okay, these particular things, these particular terminologies we'll just see in drilling. A catwalk, termed as it is termed as catwalk. On catwalk, they'll be just lowering, and they'll be rigging up. Okay, rig up. Okay, it is termed as rig up. R/U, rig up. It is termed as rig up of logging. Okay, and this logging tool will be slowly running into your wellbore. Slowly it will be running. At this particular meter, a depth sensor will be there. A pointer will be there. It is termed as depth sensor. This particular depth sensor will be telling how many meters or how much meter a cable went into your wellbore. So like this, they are going to just do. Okay, lower. So after lowering, so here there is that is an open hole wellbore. openable well. Okay, and continuous record will be there. So here there'll be this is an continuous logging tool. Is termed as Sonide. So here this Sonide or the tool will be hitting. First of all, it will be just hitting your wellbore bottom. So when they hit wellbore bottom, there will be slight change in your weight. Okay, it is termed as hook load. Hook load. Hook load weight. Hook load weight will be reduced. Okay, so when it is suspended, when this particular tool is suspended in the air or mud, it will be having different weight. When it just touch, when it is going to be touching, so when it touches your bottom of your wellbore, automatically your hook load weight will be drastically changed. Drastically change means assume that this is around maybe assume just take it as 50 kgs. Okay, this particular weight of the tool is around 50 kgs. So when it touch this particular well bore or bottom of your well bore, it will be just changing. Okay, maybe assume 40 kgs. Okay, so nearly 10 kgs of weight was changed due to hitting to the bottom of your well bore. Okay, there is a change in your hook load. At that time, they'll be telling that they reached the bottom or tool stuck at the bottom. From the bottom, they'll just go up. From the bottom, they'll just go up and readings will be from the bottom, not from the top, because we don't know at which particular depth, means we don't know how much depth this particular well is. Earlier, I just said there will be two set of depths. Okay, one is logger's depth and other one is driller's depth. One is logger's depth and other one is driller's depth. Two depths will be there. Okay, so to confirm actual depth, what is your actual depth? To confirm that one, they'll be just lowering the tool into the bottom of the wellbore. Then this tool is going to hit your bottom of your wellbore, and there is a change in hook load weight. From that one, they'll just start the pulling of your tool slowly. They'll just pull. That is pulling. Pull. It is termed as pull up. Okay, pulling. They'll be just pulling. They're going to pull. They'll be just pulling the tool to the surface. Okay, so from the bottom, you'll be readings will be there. Continuous readings or continuous record will be there. Okay, either the caliper, gamma ray, resistivity log, whatever may be, the tool will be just taking all the readings. So like this, your like this, they'll just go. So here coming to a preparation of logging program. So here the major one is that field development plan. So here the field development plan, that is an order or the procedure which should be followed. So here we just see the order which is going to be produced. So at which particular point, one sort of point, you have your well. Assume that this is an A well, exploratory well. Assume that this is one well, second well, third well, fourth well. Okay. A, so this is a well, B well, C well, D well. So these are the wells which they have drilled or they have to the plan for the proposal. Okay, first well which was drilled is termed as first well which will be drilled when which will be drilled in an area or the location is termed as exploratory well. From your exploratory wells, another wells will be drilled. Another different wells will be drilled. Those are termed as development wells or appraisal wells. Okay, some sort of wells. The terminologies they'll be just turning out. Okay, so those terminologies also we are going to just see after completion of your logging. So here, so this is the field development plan. The plan should be there. The step-by-step procedures. Okay, step-by-step procedures should be there, and they are going to follow all these particular procedures. So what are those procedures? We are going to just see now. So here, if you want, you can note it down. It is just like a thumb rule. So majorly, if you want, you can note it down for exploration wells. If it is an exploration wells, what are the common tools or common logging operations which they are going on? Just like if it is an development wells, what are your logging tools which will be used? If you want, you can just take a screenshot or you can write it down. If it is an exploration well, okay, the first and foremost well which will be drilled in an area, it is basically an unknown area which is having limited data, either seismic data, whatever may be. So whatever the data is there, limited data. With that particular limited data, the first and foremost well which will be drilled, that is termed as exploration well. If the well is success, another wells will be drilled. Those are termed as development wells. So in the development wells, generally they'll just see for so where is your oil water contact or gas. So where is your they'll be telling us oil water contact or gas oil contacts or gas, so on. Okay, so like this, development wells will be showing at which particular region this particular pay zones were extended, extension of your pay zones. So if you want to write down, you can write down this particular one. So all these things, or you can just take an screenshot. Okay, for exploration well, if it is then 17-inch, there's a well bore is 17 and half. The well bore is of 17 and half. Okay, they'll be just going with gamma resistivity sonic. If hydrocarbon or some sort of indications are there, that is hydrocarbon indications are there, but during your drilling operations, now they'll go with gamma density neutron. Okay, gamma is for lithology determination. Density and neutron, that is a combination of the two. It is going to determine whether it is oil or gas. And next one is pressure testing, that is fluid testing. So here in our delivery, we are not going to talk about well testing operations. Okay, so only the things which we are going to discuss is formation evolution, the drilling, and reservoir simulation only. Okay, well testing I am not going to teach. Well testing it is not so given for you. So maybe for maybe in the coming up they may introduce. Okay, if it is 12 and of 12 1/4 inch well bore, they'll go with LWD, gamma, and resistivity. Gamma resistivity density neutron. Just remember, if it is a density neutron, it is to determine whether it is, if it is a density neutron log, that is combination of density and neutron. Okay, to determine whether it is an oil or the gas or the water. Okay, to determine between these three formation fields, they'll just use density neutron, because water is having highest density. Density of water is in that it is 1. If it is fresh water, it is 1. If it is formation water, it will be around 1.02 or 1.04. For gas, it is around 0.6. If it is oil, it will be around 0.8 to 0.9. Okay, so density tool, it is going to give that particular values. If it is neutron, all your H plus ions, which is having highest or more H plus ions and which is having least amount of H plus ions, H plus ions will be more in your gas. Because we are going to just see methane. Okay, more amount of gas. Commonly, we'll be just saying as natural gas as methane. Okay, methane will be having more amount of H plus ions compared to your oil and water. Okay, oil and water will be having very less amount of H plus ions. Gas will be having more amount of H plus ions. Okay, and and here the fluid sampling for exploratory wells, fluid sampling is mandatory. Next one is 8.5 inch. 8.5 inch well bore LWD with gamma resistivity density neutron, gamma dipole sonic formation imager. The pressure, that is when it is pressure, it is an sampling tool. I'll just show you in a different slides. Fluid sampling, VSP, and sidewall samplings. So this is which will be done for your exploratory wells. Is it clear? So if you want, you can go for snapshot or you can just write down. The students, is it clear? Student?
Clear, sir.
Yes,
Yes,
sir.
sir.
So next one is for development wells. Okay, this is for exploration wells. This is a procedure. If you just see here for 12.5 inch, 12 1/4 or 8.5 inch, you can just see the common one is LWD. They did not went for 17.5, okay, because 17.5 is bigger wellbore diameter. Okay, bigger one compared to 12.5 or compared to 8 inch. Okay, so because of diameter change. So here, when you are going with LWD, you have to use optional tools also. That is RSS, rotary steerable systems, or mud motor systems. Okay, and small flexible type. Okay, this is your drill string. To your drill string at the end point, a small bend type of tool will be used. Okay, small bend. We can't see means if it is laid on your catwalk or somewhere else, we can't differentiate. Okay, but when you're going to lower into the elbow or when you just handle with your hand, and if you just inspect that particular one, you can just see small inclined will be there. Okay, so that is for your mud motors or rotary steerable systems. So here, when wellbore diameter is bigger, so these rotary steerable systems or RSS cannot work properly, and cost will be more when you are going for bigger or greater wellbore diameters. So next one is for development wells. So if you just see for development wells, okay, you don't see mainly for samplings. Okay, and you don't see more amount of logging tools which are used. Okay, for 7.5 inch hole, if it is 7.5 inch development well, generally they don't go with any kind of logging. Okay, that is for optional. They'll just go for optional means depending upon the company only. Depending upon the company option, they'll just go means if just like ONGC, Reliance, or Ken India, something else, ENP company, they say I want logging, they'll just go. Otherwise, they don't go. Okay, so logging is not mandatory for 17.5 inch hole section. Then, if it is 12.5 inch, either MWD, gamma ray, okay, single one, single log is sufficient, gamma ray log. Because they are going for MWD, measuring while drilling. The measuring while drilling is going to give all the details of your wellbore, continuous record, that is real time. Gamma resistivity sonic. So here, if it is of our interest, if you want to go with sampling, fluid sampling, we can go. Otherwise, no need. Okay. If it is 8.5 inch whole section, gamma resistivity density neutron, dipole sonic, formation imager, pressure, VSP, and sidewall samplings. So these are the things which will be done for your development wells. Okay, for development wells, the logging will be nearly very less or optional. Okay, they'll just go with optional, just like our open electives. Okay, means if you want to study this particular subject, or you can just leave it away, like that. Okay, depending upon the company and depending upon the budget, they'll just go.
क्या कर रहा है?
This is a thing. So next in the next class, that is tomorrow class, we'll just go with quick log interpretation. So here you can just see another is it lecture outlines. Can you see lecture outlines, students?
Yes, sir.
Can you see the lecture outlines?
Yes, sir.
Okay. So here, this is the one basic one, that is what's your formation evaluation, what we evaluate, what do we evaluate, what is the data required, what is the data which we are interested, what is the data which we are interested, who needs this particular data, what type of tools and methodology, and summary and references. So if you just see this particular formation evaluation with respect to your depth or whatever the requirements are there, okay, what is the type of your geological type, whether it is sandstone, claystone, siltstone, mudstone, whatever may be. Okay, so formation evaluation will be dealing about those particular things, and mainly your petrophysicist who is going to be present, he is going to take all these particular things. And what we are going to evaluate, whether it is on oil or gas, where they are located, or how much they are present. Okay, here where they are located means the type of traps, whether it is an anticline, a sink, whether it is an anticline, which type of fault, like this. Okay, where they are located, it can be a salt dome structure, whether it can be a salt dome structure, or it can be an anticline like this, or salt dome structure, or it can be a fault, or it can be a statical trap or structural trap, or it can be a depth, maybe at 1500 meters, 100 meters, 200 meters, 1000 meters, 2000 meters, like this. And how much they are going to be present, quantity which they are present, so like this.
Okay.
So these are the questions which we are going to make. Generally, this type of questions will be asked from the company side, and what we are going to evaluate. So reservoir. So we are going to evaluate the reservoir. So which type of reservoir it is, whether it is an sandstone or whether it is a limestone type of reservoirs. Okay, type of reservoirs, whether these particular reservoirs are going to contain hydrocarbons or not. Okay, and type of just now we just seen the trap. So that is which type of traps are there, whether it is a structural trap or stratigraphical trap, like this. Okay, the source rock, type of your source rock, what is the permeability and porosity is, and type of your hydrocarbons, whether it is oil or the gas. Okay, next one is what is the data which we are interested. Okay, so mainly the data which we are going to take, or which we are going to just see the type of rock type. So here when they say the type of rock, it can be shale, what is it? It can be a shale, that is shale formation, whether it is shale, whether it is a shale, whether it is a limestone, whether it is a sandstone, whether it's a mudstone, whether it is a clay stone, like this. Okay, so like this, they are going to just see, and they are going to just see the porosity. What is the porosity? Porosity, the fluid saturation volumes. So when it is a single reservoir, single means when it is only pure form of oil or pure form of your gas. Okay, this particular saturation, that is SW or S4 or SG. SW or SG or S4 saturation will be equal to 1. Whether it is, if it combination, that is saturation of your water with the gas saturation, then it will be less than 1. But a single reservoir, that is single component, if it is single fluid, whether it is water alone or gas alone or it is the oil alone, it is going to be equal to 1. Saturation is 1. When it is combination, it is going to be less than 1. It's going to be less than 1. It can be water, pure oil, or gas with oil. Okay, so like this. So when it is 3 components, automatically it will be very less. Okay, fluid saturation volumes. So everything they are going to just calculate. And type of fluid. Okay, whether it is oil, gas, and whether it is oil, gas, or water, type of fluid. Okay, when they are going to say or talk about that type of fluid, that is your formation fluids. So formation fluids, it can be a water also, water, oil, or the gas. Okay, so reservoir structure, just now we said anticline or syncline, fault, like this, permeability, reservoir pressures, like this. So this is the data which they are going to take it out. Okay. So these are the techniques means by using satellite, how much meters or magnitude they can just go like this. So who is going to need this particular data? A geologist. A geologist is going to take its time depth. So that is generally it is seismic. Okay, time depth relations. I'll just show you the figure of seismic. A geologist is very much interested in whatever we just seen just above. That is stratigraphy, structural sort of figures, each and everything. Reservoir engineer is going to be very much interested in porosity, permeability, fluid contacts, like this. And drilling engineer will be only for the targets, the depths, the targets and depths, like this. Okay, production engineer, fluid pressures, flow, type of flow, whether it's a single flow, gel flow, multiple flow, like this. Manager is an company person. And government, so it's going to take all your records and each and everything. Okay, whatever the drilling is there, whatever the logging is there, each and everything should be submitted to the government agency. So next one is a methodology for your formation evaluation methodology. So here, to get your formation evaluation, okay, so different methodologies we are going to use. So one is seismic survey, mud logging. So in our context, we are going to just see what's the mud logging. We are going to just study about well logging. Okay. The coring, a little bit I'll just tell during your drilling operations. The fluid sampling, well testing, seismics, MWD and LWD. Okay. So these are your methodologies through which you are going to have your formation, the formation evaluation. That is the data from where you are going to just acquire. So here, this is an seismic survey. The seismic survey is going to give your a subsurface image of your subsurface. Okay, just like seeing ourselves in the mirror. Simple thing, I'll just tell you in a simple manner. Just assume that it's a mirror. This is a mirror and an object. An object is here. Okay, just an object. So when this particular object falls on the mirror, this object will be reflected. The same object will be reflected. The same thing will be happen in your seismic also. So here, this is for your marine operation. This is marine operations. The seismic vessel will be there. This is for your land. Different seismic procedures will be there. Okay, means as we are not dealing with these things, I'm not going to discuss much. So this is an vibrating truck. It is termed as vibrosis. This is going to produce some sort of echoes or sound. Echo or sound, and sound is going to be reflecting, or it's going to travel. It's going to hit your rock formation and it's going to travel to your surface. This travel time, it is termed as travel time. This travel time is going to be recorded. So when they're going to fall like this, you're going to have the shape of your formations. So this shape will be recorded. Here you have your recorders. These are termed as recorders, or receivers will be there. If it is in water body, it is termed as hydrophones. If it is for land bodies, it is termed as geophones. Geo is going to refer land. Hydro is going to refer water. And these phones will be producing some sort of record. So this record will be time with respect to your depth. Time with respect to your depth. So don't forget time with respect to your depth. Time versus depth. Okay. From time versus depth, you are going to have the data. All the data will be there with respect to your depth. How much time? Okay. This time from this one, they are going to calculate the velocity v equal to distance by time. Distance by time. So we know. Actually, here we don't know the distance, but we know the velocity and we know the time. Okay, at what velocity it is going to signals are going to pass into your subsurface, and at what speed they are going to come back. Okay, velocities, we know the velocity. Only the depth is unknown. From here, they'll just calculate at which particular depth your actual reservoir is there. I'll just zoom it out, so that you can just see some sort of small sort of things. So here, if you just view, if you just see clearly at this particular,
Can't see.
this particular red mark, I just circled. Visible?
Yes, sir.
Okay. So here you can just see at one particular point. I just change the color. From here to here. From here up to this particular point, there is some sort of continuity, and again you can just see at this particular point, and again at this particular point. So from here they'll just tell that there is some sort of discontinuity somewhere else. This discontinuity, they'll tell it can be a fault. Okay, it can be a fault sort of thing, or if it is structure. If you are going to just see this sort of things. So here if you just see, so you can just see very clearly this this particular one is going to represent your salt dome structure. salt dome structure. So here, when you just see here at this particular region, the signals at this particular point or in this particular region, okay, so you can't see any sort of signals properly. Everything is hazy type. The signals or waves are hazy. So here you can just see the signals continuity, and up here you can just see like this, and anticline structure is there, but below this particular one you can just see the hazy one. So by showing the particular hazy one, they are going to tell it is an saldom structures. So like this, okay. And if you just see here, they just drawn some sort of lines. You can just see here some sort of lines they drawn. Okay, these lines are representing your fault lines. Fault lines. Either it can be a reverse fault or it can be a normal fault. Okay, it is on fault lines. This is an operation of mud logging. I'll just show you in the next class. So this is your MWD. This is a particular data which they're going to get. So if you want, you can just take a snapshot. If you want, you can just take a snapshot. And these are the tools. So here they'll just join one tool to another. They'll just screw. They'll just like screwing. Okay, tightening. They're going to just tightening the tools one to another joint. Okay, if you just see this is your bottom hole assembly. This is your drill bit. Will be like this, and this is your RSS or rotary steerable systems like this. And they'll just so here like this they'll just attach. They'll just bring to your surface up to your rig floor, and from the rig floor here you can just see the picture. They'll just tighten, and they'll just bring to your rig floor, and from there they'll just send your tool into your well bore. So this is the data which you are going to get from your logging. For
Sir,
sir,
you have not changed the slide, sir.
I think it will be changing. So now the data from white line.
No, sir. So it is showing quick look log interpretation.
Okay. So anyhow, so now it is time is up. Let's see. We'll just see in the next class. I'll just continue with this particular one only in the next class. This whatever I'm going to show now, just like extra sort of topic only, just for your basic understanding. The next class again, I'm going to just repeat. So what are the things will be there, how they're going to do, the basic things which will be present.
So are we going to get that PDF on our LMS account?
Pardon?
Are we going to get that PDF that you shared on the screen on our LMS account?
Just chart, give the message.
Yes, sir.
Because I think exactly at 7 o'clock, this will be ending. Okay, I'll just I will share. I will just view to this. Okay, I'll just view this particular topics to the authority person, that is technog person. I'll just send them. I think they'll just upload. I don't know all this particular uploading in LMS and everything, so they'll just do these particular things. Okay. I'll whatever we are going to just discuss, I'll just give them and they'll be just uploading.
Sir, any references, book or website you gonna like tell us, because for reflection or like for further reading?
Textbooks.
Yeah, textbook or like some websites or some tutorials on internet or anything.
Okay. So if you want, means if you want extra sort of things, you can go with the YouTube, or you can go with the Slimberger website, SLB. Slimberger website, slb.com. slb.com. There they'll just view all sort of details of their logs, and they'll just view some downloading also. They'll just do some sort of downloads where you can just go, and some sort of textbooks are there. Lynch, formation evaluation by Lynch. Formation evaluation by Lynch. That one also, that particular textbook is also good textbook for your basic understanding and everything. And in due course of time, I'll just tell you so what are the things also.
Sir, excuse me, sir.
Oh yeah. Yes.
Like we had particularly taken for like managed pressure drilling, sir. Like will these basics help in that, sir, for that managed pressure drilling?
So here I'll be just coming step by step. First one, I'm going with formation evaluation. After completion of formation evaluation, I'll start drilling. So in the drilling, basic concepts of all the drilling operations and managed drilling. Okay, and then reservoir simulation. Like this, step by step. That is your entire sort of syllabus. Formation evaluation, how they're going to do, and after completion of this particular one, after completion of this particular one, I am going to just show this particular log tool, how logging will be done. Means after, can you see this particular screen now?
Yes, sir.
Just wait. This is an log plot. Okay, so this is a log plot. In this particular log plot, how we are going to just this is a demo version. Okay, this is not an original version. It's a demo version. How we are going to view the data. Okay, and how we are going to give this lithology. What type of lithologies we are going to give, and how we are going to plot the graph. Okay, like this. So finally, the log will be there. So here, how this particular plot will be there, everything we are going to just see after completion of our logging. Okay, basic concepts. I am going to deal about this particular software. Here.
Okay, sir.
So this is the thing.
Okay, sir.
I think our time is only from 6 to 7. And tomorrow we'll just see about quick log interpretation.
Okay, sir.
So here you can just take while I'm going to take the lecture, you can just take some snapshots also. It will be useful for your future jobs. Means after completion of your engineering or after completion of your MSc, so it will be generally useful during your training period or when you want to go for interviews. Companies will be just asking, so it can be useful for you.
Okay, sir.
Can you tell us about like ID, past examination?
Just send a message. Type the message. In the, this rig pass and everything I'm not going to teach because I'm not an specialized trainer for those things. IWCF and everything I'm not going to tell, but so if you just like if you want to just see not the rig pass and everything, if you want to get some sort of global certificate, or if you want to see just like certificate type, if you want to get the certificate type level 1, just type in website or Google, just type in Google level 1 IWCF, level 1 IWCF. This is going to give the basic introductions of all the drilling operations which are present, how the tool will be there, what type of tools are there, like this, what's the preparation jobs, each and everything they'll be just giving in the Google. Level 1.
Is it well controlled operations?
IWCF, level 1 IWCF, well control operations. Okay. So there you have to sign in. You have to create an account. So that particular one is free of cost. It is sponsored by Petro, LNG, or some companies there. So that particular company is going to.
Sir, is that certificate useful, sir? IWCF?
That is an just like training only. Okay, means it's going to just give some sort of basic introductions only. It is not an useful one. Just like basic introductions. If you just go to any other institutes, the same thing they'll just tell. Nothing different. Okay, this website, you're going to just sign in, login. It was sponsored by Petrofac. Okay, Petrofac is sponsored for this particular one. So means for your engineering, I think they'll just ask some sort of certificates, online certificates to be done. So for this one, this will be suitable for you. 2 courses will be there, level 1 and level 2. Level 1 is basic drilling operations, all your drilling operations which will be carried out in rig or at your rig site, either in offshore or on land. Level 2 is there. Level 2 is for HR, that is thematics, HR relations. How that is behavioral attitudes. So these two you can do. I think the main techno person is not there. Then previously at 7 o'clock, exactly at 7 o'clock, it was ended. So as some of you are in 3rd year, if you are going for any kind of projects, any sort of things, okay, I can guide you. Means I can just do the basic sort of things. How can you go and how can you do the works?
Excuse me, sir.
Tell me.
Yes, sir. So am I audible?
Yeah, you are audible.
Yes, sir. So like my stream is like, sir, my stream downstream, and I'm not from petroleum domain actually. I'm from, but I want to join job of upstream.
Just can you send the message? Just send a message, Abhishek. If you are an petroleum graduate, I think everything they'll just deal upstream, midstream, and downstream. All the streams will be there. So here, generally for petroleum, are you petroleum engineer, Abhishek? The petrochemical. So to get in upstream, generally oil companies, just like your ONGC, Reliance, Care India, generally these companies they don't take in upstream because in upstream activities it will be in an it will be exploration part, exploration activities. Those exploration activities are just like seismic, gravity, magnetic, geological survey, geophysical survey of these. So for this particular one, generally will not be suitable. Will not be suitable for upstream activities. But if you write the gate gate exam, and if you just qualify in the gate exam, so there can be chances to go into your upstream domain, or you can go into the upstream sector. All the government companies will be they'll be having the gate. If you just qualify in the gate exam, there is a chance to go into the upstream.
Okay, sir. Thank you.
Okay. So now I'm going to end the section, and tomorrow we are going to just discuss with another topic. That is a little bit of the topic is only one slide topic, and tomorrow we'll just see with another set of discussions. Okay, after completion of our topic, and we'll just go with another set of discussions. So good night. Have a nice day.
Thank you, sir.
Thank you, sir.